Hello, I am the captain of the Brain Explorer, a nano submarine. I am recording as I finally arrive at a very important part of the human brain to interview one of the neurons. Perhaps some of you might have heard that a long time ago, skin cells evolved and began to carry signals from one part of the body to another. Very simple organisms with nerve cells had better chance at staying alive. A bee has a brain with 900 neurons and does a lot. The human brain is a beneficiary of hundreds of millions of years old evolution and is the most complex machinery in the universe, with about 50 billion neurons working together. I am able to speak the binary language of the nerve cells, fire or not fire, quite fluently just in case. This little neuron is part of the command and control center known as the Reticular Activating System. Please join me. Hello, little neuron. I am captain of the Brain Explorer, parking my submarine right in front of you.
Hello, Captain. Thanks for visiting. What brings you here?
I'm hoping you could answer some questions.
It's all right. Go ahead.
My first question is, how did you get your job at the Control and Command Center?
My DNA genetic code sealed my destiny. Don't think, like other people have done in the past, that DNA is like my own little brain. It is more like a copying machine, a robot. This robot is controlled by my environment and by the presence of other neurons and glial cells.
This is new to me.
My environment is full of chemical signals that act on the antenna receptors on my membrane or cell wall, and these relay messages to the proteins inside my body that activate a certain part of the DNA robot and tell it what new proteins to produce. So DNA reacts to my environment.
Wow, this is absolutely amazing. I'm so glad I came to talk to you. I think I'll learn a lot.
I hope so. And, by the way, this is also how DNA knew how to control the growth of my axon. You see it here? This long cable reaches out to communicate with many other neurons at the same time. Every connection is called a synapse.
Please, describe your journey.
Neurons begin to reproduce very fast as the baby starts growing inside the womb. Then we have to race to find our own spot. Some of us have to travel about an inch, but given our itsy teeny weeny small size, that is like a person walking from New York to Los Angeles.
That's a very long trip. How did you manage?
We use glial cells in the brain as rails and providers of food and energy. Once we arrive to our destination, we concentrate on connecting to other neurons. I am now 11 years old. We stopped multiplying when I was 6, and our connections were still scarce. We keep learning every day and have a lot to learn. All the neurons you see beside me are the ones that won the race. Those neurons that lost the race have a sad ending.
What do you mean by a sad ending?
It means that neurons can't connect properly, have to vanish. No sense wasting precious sugar.
Yes, I know that brains and neurons use carbohydrates as fuel. The body of a grown-up person consumes the energy of a 100-watt light bulb. Somewhere between 20 and 40 watts are used by the brain. That's a lot.
Please take note that we are specifically programmed to do our jobs or get out of the way.
It sounds awful, but think of it this way. Most nerve cells live a really long time. Certainly much longer than red blood cells, skin cells, or bone cells.
We have to because we carry the information that keeps a person alive.
That's why the brain is kept floating inside a thick head for protection. It's like the ROM, RAM, and solid-state drive and software of a gigantic computer, all rolled into one device.
Yes, but we are flesh, not metal or silicon. And the brain can adapt and change its own structure.
All of that computing power and flexibility depends on the tiny synapses, where the axon connectors of one cell and the dendrites of thousands of others come together. Can I see what a synapse looks like?
Sure you can. You must follow my axon all the way to a synapse. Each axon has many tips branching out to other neurons. You'll arrive at a big bell-shaped hole with a round, flat wall on the bottom. When an electrical signal gets there, the neurotransmitters are released and cross the synapse and settle in the dendrite receptors. This transfers the signal to that other neuron. Sometimes, the electric current jumps directly. Some connections are on-off switches and some are analogic. Each little nerve cell is really more complex than any computer ever invented.
RAS neurons like yourself have very long axons. Why is this? What exactly do you do?
The RAS is a control and command center located right in the middle of all the action. We are like huge telephone exchange that connects to the older parts of the brain and the newer parts of the brain. We are sending calls and getting calls all the time. We are also in charge of keeping the thinking brain awake and alert most of the time.
Wait a second, what do you mean the older parts of the brain?
I'm talking about a part of the human brain looks and works very much like the older brains of snakes, lizards, and even dinosaurs. It controls life support, such as breathing and heart rate.
Not very smart, but very good for smelling food and trouble. So the RAS is in the brainstem and is part of the old brain. The cerebellum is behind you guys, giving support to motor movement control.
Built on top of this primitive brain is the limbic system, a brain addition which is present in all mammals, such as dogs, dolphins, elephants, and humans. It helps control body temperature, blood pressure, and sugar levels, among other things.
A big step for warm-blooded creatures. Much smarter, can learn a lot of tricks, but still at an emotional level.
That's correct. And on top of that is the cortex and the strictly human brain. The neurocortex with a tremendously high concentration of neurons and synaptic connections.
Oh, I get it. The human brain is like a new building, which was built without tearing down the old building.
So here I am working in a remodeled old building where I get a lot of information processing requests from the body below me and intelligent instructions from the brain above me, how I relay what is important. The old brain regulates instinctive and automatic chores having to do with body satisfaction.
How do you know who to listen to? The new brain or the older instinctive brain? How do you guys communicate and make decisions?
Let's say that every neuron has a phone line to a certain part of the brain. Now imagine that each cell can also receive 10,000 incoming calls at the same time. Some of these say fire, others say don't fire. So we like to think we are very democratic. If a majority of calls tells me to fire, I fire. If many more calls say do not fire, then I do not fire.
Once you fire, you are now the one thing that is telling the bunch of neurons what to do. So what?
This is where specialization comes in. The key to making the brain work is cooperation. Several cells join the net, and several nets become a team. Teams become systems with specific functions. There are many different teams of cells, some very large, some quite small. Some teams manage what happens inside the body. Other teams try to control what happens outside. The control and command center is like an inside-outside switch that controls what needs paying attention.
So, how many teams are you talking about?
There are many teams. Some are pre-wired for life. The vital functions, for instance. Breathing is pre-wired. You cannot stop breathing for long. Hunger is also pre-wired for life. The rest are good at learning and get wired every time you learn something new. So there's a bunch of them.
So the brain breaks up its work into many different jobs?
Yes, very many. The brain is a self-organizing system. Some teams become good at recognizing patterns, others become good at counting. Some are good at making comparisons, others specialize in storing and retrieving information. Other teams follow stories, and so on. When you combine several of these teams, you get a very flexible brain with a lot of control and learning potential.
Please explain to me how the team is formed.
Those cells that are not hardwired become teams mostly by trial and error. Basic learning. Playing golf is an example. It looks so easy on TV, but it takes years to play really, really well.
Which means teams are formed as they learn to correct mistakes.
Actually, we learn faster from mistakes than from being correct. Even cells of hardwired teams have to learn, and they start practicing even before the whole system is working.
We have a very important rule. Neurons that fire together wire together.
Thank you guys. Don't forget, use it or lose it. Synapses that are not used are lost. This means that when several guys fire together, then these synapses are made stronger and likelier to fire together again when the same situation arises. This is how the brain learns. It is a very basic control loop. When brains face the same need, messages are sent to the neurons that solved the problem last time. This process is self-adjusting and gets better with practice.
Is it correct to say that learning is making adjustments?
All special teams have their own rules for firing or not firing. The team acts as if they were a little person that needs to shout to be heard by other teams.
Give me an example of one such rule.
Rules are the equivalent of if-then statements of a computer program. If this happens, then do this. Rules are similar to software, as in that the brain uses special teams with opposite purposes to get things done. For instance, one team is enjoying playing football and another team is getting thirsty. You continue to play until you have too much thirst. The brain works by balancing the signals from one team and the signals from another team. The control and command center then decides which team is shouting the loudest.
Here I am looking out from the window of my sub. I have a perfect 3D TV image in my mind of you standing there outside the sub. How did this image get inside of me?
Vision, for instance, requires many sets of teams working together. One works with edges, another with patterns, others with colors, another with 3D. Then the output converges on other teams and so on to produce the three-dimensional perfect resolution TV screen appearing before your eyes. Millions and millions of these little neurons, like myself, work together to build a picture inside your head. That picture feels exactly like the real thing and is a real thing for all you care.
So, you're saying I'm not looking at the real world, but an illusion portrayed by my mental screen?
Yes, a perfect illusion. A screen that matches the world and allows you to grab and drink a glass of water. It's like watching a football game on TV. You know the stadium is far away. You know that touching the screen is not touching the players. Everything you see is built from the signals we guys produce. But the TV screen is in your head.
This must be one of nature's biggest magic tricks. Many people agree that there is a real world out there, and it is only because we know that we can trust this illusion.
When you add all the signals coming from your body, your position, smell, touch, and sounds, and sense of location, you prove to yourself that you are seeing the real world outside as something different from yourself.
I noticed that the neocortex has many layers of cells. I guess a lot of space is needed for all the information processing that is going on.
The folds in the neocortex is nature's solution for fitting a lot of brain power into a very small space. Nature uses the mathematical recursive procedures discovered by Mandelbrot.
Now I understand why the neocortex of humans is 10 times larger than that of a macaque monkey. Layers and layers of teams do what only humans can do. That requires a lot of processing space.
Well, you see, our secret is clever use of memory. Teams are very good at remembering and learning things. The guys upstairs store pictures or models of things that look a lot like the original. Creating models allows them the best use of memory space. They do not have to store everything they see about a chair. They store a model of that chair, then another and another. Soon after a team figures out what a chair usually has 4 legs and a place to sit and back, the higher regions of the brain are compulsive model builders. This is how we figure out that nature is repetitive. This helps us predict what the world is like and what the world is doing. Prediction is the key to perception.
Gee, I never saw neurons as compulsive model builders. That explains why parts of the brain keep working while we sleep and while we dream.
Several small teams hook up to another team at a higher level. Then several of these connect to a still larger team, and so on, till you reach your identity and produce thoughts. When you act, your thoughts create signals that follow a reverse path downwards towards execution levels passing through the RAS team. This is how your thoughts also strengthen new synapse connections. Your thoughts literally change your brain.
So, What other teams are important?
There are teams for short-term memory, remembering what just happened. Long-term memory remembers what happened long ago if it was important, or linked to an emotion. We are in charge of sleep because sleep helps create long-term memory. By the way, we also inhibit the muscles while you sleep.
Besides memorizing models of things, do neurons memorize processes?
Yes, of course, some teams are good at always following the story. Everything that happens to other memory teams are linked to the main story. Where you were, who was with you, the time of day. So next time when you talk to the red sports car you liked, remember the place, the salesman, and who went with you. Teams work together to remember things in stories. Remembering stories is a lot of fun and easy on the memory because so many teams collaborate. We love to cooperate a lot, although sometimes, as I said, we have to vote against other systems to get something done.
Besides memorizing models of things, do neurons memorize processes?
Yes, of course, some teams are good at always following the story. Everything that happens to other memory teams are linked to the main story. Where you were, who was with you, the time of day. So next time when you talk to the red sports car you liked, remember the place, the salesman, and who went with you. Teams work together to remember things in stories. Remembering stories is a lot of fun and easy on the memory because so many teams collaborate. We love to cooperate a lot, although sometimes, as I said, we have to vote against other systems to get something done.
In this mental trilogy, which of these three masters is most important?
Emotions get priority as a first and very fast response. The emotion circuit works automatically without conscious thinking. You jump when you see a snake. Your heart beats faster. These are emotional responses. Everything the brain considers immediately important is handled at the action-reaction emotion loop.
So emotions are linked to primitive survival reactions.
Emotions are also important because they reinforce synaptic connections and activate convergent learning. So you learn best when emotions are involved. Thrills and chills make more synaptic connections.
Do emotions have a special team of their own?
The guys that take care of quick emotional reactions are the guys that work at the little almond in the brain, the amygdala. A heart beating fast suddenly or sweaty pants prepare you for emergency action, fight or flight in the face of danger.
What about motivations? What are these?
Motivations can sometimes result from emotions, but are slower response. Motivations are demands for action that usually come from physical or psychological needs. Motivations are a pulling force that guides your action towards a certain goal. You are motivated to study because you wanted to become an engineer. A goal in the future pulls you toward in the present. Animals show motivation and learn to get results too.
What about cognition? A word which comes from the Greek word that means to know something.
Higher cognition is only present in humans. It requires understanding. Humans can override motivations and even some emotions. Cognition requires intelligence, manipulating ideas, beliefs, knowledge in your head, and playing with different scenarios.
Why do you say that these higher brain functions depend heavily upon memory?
Because many problems are solved by ingenious use of memory. Except for involuntary responses, most teams in the brain have to learn what they do. And learning requires tons of memory capacity to store experiences, perceive, juggle images, and make comparisons.
You said earlier that brains work using prediction and difference. Please explain.
To perceive something, you first make a prediction and then compare that with what you saw. The difference or error message goes around and around this loop very fast, getting smaller and smaller. In 100 milliseconds, you are fine-tuning the image you see, hear, smell, and feel on the 3D surround sound theater inside your head.
Who runs the whole show?
Emotions, motivations, and intelligence should work for the better, but people use different mixes. We, at the RAS, or Control and Command Center, are the managers dealing with everything up and down the spinal cord, sensations and commands. The information from senses, such as vision, sound, smell, pass through us so we can alert the top management. With help from the limbic system, we help keep vital functions in balance. We connect emotions to the higher management, which has final decision power over us.
This looks a lot like legislative and executive powers of government. Who is this higher management?
Let's say that we are part of lower management and higher management at the same time. We are directors of the lower floors, and we also execute final instructions from the 2 floors above, intelligence and identity.
What is the difference between them?
Intelligence gathers information from the outside world that enters through the senses of sight, hearing, balance, taste, and smell. These same signals pass through the perception and attention filters that we control at RAS, so we may alert the top management. Then, the whole package gets processed and compressed to the information residing in the memory banks. This way, intelligence is constantly making pictures of available alternatives. For instance, things within your reach, escape routes, noticing facial expressions of people you are talking to.
You control which things the brain pays attention to?
Yes, for instance, mothers have a special attention switch to hear their babies cry. The higher brain also programs parts of the command and control center to pay attention to other things. For instance, when we hear about politics, region, or a familiar name.
What is the job of the guys at the final top floor, the one you call identity?
This is the final control floor. For instance, it provides balance to the command and control center and intelligence. You see, these 2 great big teams have opposite views. If every effort is spent on physical requests, then you'll never have a plan for finding food tomorrow. Identity monitors and make final decisions.
Once again, the idea of balance appears as a big factor in brain operation.
Identity also contains your very complex belief system. Lessons to the prefrontal cortex can lower more standards and empathy towards other people's situations.
As a mechanical engineer, I never gave much thought to that. I live in a cause and effect world.
Not entirely. Beliefs are the assumptions you make about the world. Beliefs are necessary to fill the gaps in your knowledge. Where knowledge stops, beliefs take over. It happens all the time.
Sounds like you're saying we do not have an option.
You don't. As I explained earlier, the brain works by noticing differences. So in order to build preliminary models, you use knowledge or beliefs until the image is clear. This is why optical illusions seem to play games with the brain, switching images back and forth. However, when your knowledge goes one way and your beliefs another, or you feel totally ignorant, you become a victim of anxiety, and we have to jump into the lower cortex activity and prevent harmful stress.
So knowledge and beliefs work together?
Yes, there is plenty of map making to do. So between them, they generate rules on how to interpret the world. Sometimes these rules become programmed as our perception and attention filters. When this happens, we run on autopilot, navigating automatically. This is the reason why people with strong beliefs are very hard to change. Beliefs take over to the extent that these people literally can't see what is in front of them. So in essence, beliefs and knowledge create a hardcore set of rules or values that control identity and have the supreme power over the person's behavior.
So, the identity team is a person's own sovereign government.
As I said, the identity team chooses which rules and behaviors are worthy of the image the person is trying to validate. If you are a baseball player, maybe you want to emulate Baby Ruth or Mickey Mantle or a combination of the best pitchers ever. This identity filters out unworthy behaviors. Everybody makes his own rules on how to perceive the world.
Are there any universal identity components?
In the end, every person has a physiological and psychological need to be wanted, appreciated, loved, and respected.
But do you know why?
Probably because it makes us, the neurons, feel really good. This is genetic. We cherish being connected. When we are disconnected, we die, and we do not want that. The more connections, the better. This is why little children are usually very happy. The more they are learning and making zillions of new connections every day to the way that the world works and to other persons, large and small, busy, connected people live better and longer.
What role do rewards play in all of this?
First of all, rewards make us love our job. For instance, when we solve a problem, that brings a satisfaction reward. The chemical release strengthens the synapse involved in the successful connection. It feels great.
Where do these rewards come from?
Some teams are in charge of producing and delivering the rewards, such as dopamine and endorphin. Rewards help us strengthen synapses that did something right and make us fire together next time. Other rewards come from hormone production located outside the brain. Adrenaline fuels the emotional circuits. All this makes the brain self-organizing.
So neurons learn like puppies and want a cookie. Are the two brain hemispheres competing?
It's exactly the same thing. If my body does something good and gets rewarded, I get rewarded too.
Are the two brain hemispheres competing?
Actually, these two teams are complementary. The left side of the brain is more of an engineer. The right side is an artist. They use different logics, cause and effect, and circular. Sometimes you solve a problem using mathematics and logic. Sometimes you use intuition. Parts of the left side have also specialized in language, which gives humans the enormous advantage of communicating and manipulating ideas. The hemispheres are connected by the corpus callosum, which allows them to communicate and coordinate.
What happens when neurons get injured really bad?
It is a disaster. For instance, when the long axons of the spine get severed, the neurons die, and this has a domino effect on their neighbors, who also quit their jobs and disconnect. Sadly, disconnection means self-destruction automatically.
I once made a trip to the brain of a drug addict. What I noticed was a lot of empty space, a lot of missing brain tissue. It was like a trip to deep space. The equivalent of thousands of miles for my tiny sub, navigating in a sea of watery substance, in the most absolute darkness. It was horrible. No neurons anywhere to be found. And when I reached the neurons, their sparks lacked all vitality. They seemed to ask for more drugs to sharpen up. Sad, depressing voyage.
Yes, that is a really sad sight to contemplate. Neurons begging for drugs, inflicting pain on the rest of the body, using blackmail, all because the natural reward mechanisms have been destroyed. Addiction destroys synapses, and eventually billions of cells have no choice but to self-destruct. Teams of sick neurons produce horrible hallucinations as they try in vain to reconnect with their missing partners. It's very hard, if not impossible, for an addict to get back on track again.
Some people get a lot done in life. Intelligent and decisive persons do not allow the trivial or the animal instincts to overrule what their identity tells them they can be. You can't stop breathing, but you can quit smoking or never start. The same goes for alcohol or drugs.
The message I want you to take with you is that individual neurons are defenseless against drugs. Only humans have top management with free will. Animals that are hooked on drugs will always go for the drugs. As I said earlier, we are pre-programmed to do what we do. As individuals, we cannot change that.
I thought you said the different teams compete for the final decisions taken.
Yes, that is correct. But neither neurons nor teams are responsible for falling for the drugs. We are the slaves of the body's internal environment. It is the person who has free will to choose his or her environment and ours. Keeping company with people who use drugs is a big risk. Artists and rock stars that use drugs are polluters of the brain environment by spreading bad memes on magazines and TV.
Yes, I know what memes are. They are packages of rules, built or adopted by the identity team that jump from one brain to another. Come to think of it, from your perspective, I really do not understand why we accept known drug addicts to appear on public TV, spreading the bad memes to grown-ups and children alike, making copies of themselves inside other people's heads. What do you think of that?
Once a person's identity fails, teams collapse and neurons collapse, and before you know it, you are a different you, disconnected from the people that love you.
So, once I only love myself, I can lie, cheat, and steal from others.
You never cheat yourself completely. It is just that the good guy within you is not the pilot anymore. When internal teams break down, neurons go into a tailspin.
What can you do against invading memes?
Your life is an expression of your brain, like music playing on an iPod. Some of it's good, some of it is awful. Do you find the music if you take the electronics out of an iPod apart? No, the iPod only plays a song that you choose to download from the internet. I cannot do anything else. The same here. Each neuron is like a component of the iPod. We do what we do. The inputs from the environment shape our synapses. We learn according to the previous experience, isolated from the real world. We only apply what we learned. Only the whole person can change his or her environments and choose to feed and teach us things that are safe and not self-destructive.
I see our conversation has gone around a great big circle, back to the beginning when you first said that the neuron's DNA is controlled by its environment.
The same is true for all the cells in the body. We have two operation modes, growth and protection against toxins. But we cannot protect against man-made drugs because natural drugs are a good thing, as I said before. It is the artificial stuff that destroys us.
So, is it up to me to decide who to make friends with, who to visit, who to love, who to idolize?
This is the easiest way to put it. There are lots of nice, clean fun to go around. Making the world a better place should be a lot of fun too. Take this message with you. Choose your friends. Rebuild the world.
It seems to me that we have to rebuild what many people think before we have any chance of saving planet Earth from air and water pollution. Mental pollution is going around unchecked. Anything you might wish to add?
Yes, it is clear to us that something is intangible as a simple thought, with no material existence at all, can change us. It can change the circuits in your brain. It can change what you do and who you are for the better. It all depends on what beliefs, knowledge, desires, and fears you choose to put in your head in the first place. If you put negative images, guess what is going to happen? Craving excess food can make you fat. On the opposite side, love is about participating and creating. Thinking positively is healthy beyond anything you can imagine and contagious too.
Thank you, my little friend. I think you have done a lot today. Thanks for sharing with me your views about your situation. It has been a great help for me and hopefully for others. Onwards with the rest of my mission. Goodbye.
Farewell, Captain.